you keep seeing the map fly by. So last year was the first year we got going with Location Tech. We decided to do events like this and collaborate with a lot of local meetups and do what we can to help them. And we did 6 events. It was a huge success. There were about 723 people who were participating. So we decided to do it again this year, and actually I'm really grateful that the organizers who organized last year also came back this year, so we didn't scare them away too much. This year it got out of hand, so we did 18 events around the world, including this one here. Actually, we're going to be in Washington on Thursday. We were in Boston last night, so if you're interested in getting involved in the community, that's a great way to learn and basically learn about some great companies and great technology and meet some smart people. So that's a sort of a nice segue into what Location Tech is. There's sort of 2 sides to Location Tech. One side is sort of an R&D community, people who are doing cool things with useful technology. Now, that sounds very code slinger, techie heavy. It is a little bit, but we also like to reach out to people who are just solving useful problems. So if you're looking to learn how to use these technologies to solve useful problems to make society better, it's a great way to get involved. The other side of it is the trade association side of it. So they're companies that are building great products and services and helping to make the world a better place. And you're going to see a little bit about some of them tonight. So the other people I'd like to thank are the tour sponsors. So there's great companies like Azavia and Boundless and Mapzen and Oracle and OS Geo. These guys are the ones who basically paid money to help pay for the pizza, pay for the beer, and throw a great show. So if you would, please, another round of applause. So on that note, I wanted to thank you guys for coming. Also to thank the speakers, because you guys sharing your knowledge and your experience makes this a really fantastic event. So I hope you guys enjoy the event, and I'll be hanging around later if anybody wants to talk with me. I'd love to hear about what you guys are doing. So thanks very much.
Thank you, Andrew. Any other Canadians in the house? Whoa, it's so red here, I can't see. This is also GeoNYC. It's a monthly meetup where we talk about the latest and breaking of geo events and tools in the city. To kick us off, we usually start off with the Geo News. So I'll hand it off to Andrew Hill of CartoDB. Thank you.
Thanks, Alyssa. I was told there was a clicker up here. Cool. So hi, everybody. It is fairly bright up here, not going to lie. So I give you the Geo News every month, and so you all have, any of you that have been to GeoNYC in the past know that I spend the 15 minutes before GeoNYC trying to find all the news of the last 30 or 31 days. So I did my best to do that, and I didn't find a lot that I wanted to highlight tonight. So everybody else that has come to GeoNYC knows that then I fill it with cool maps and articles that I've seen. And so here you go. If you are still looking for gift ideas for the holidays, maybe you saw these, the printable wearable maps. These are all over the web and Twitter that you can find the person that's making these on-demand map clothing. Pretty cool. I bought myself a jumpsuit. And I also wanted to point out a couple events that are coming up. First one is Phos4G North America, which Andrew Ross knows quite a bit about. It's paired up with Location Tech again, and they just released their accepted talks, so you can go check that out and evaluate how important it is for you to travel there, because the answer is it's very important. It should be a lot of fun. Also, Location Tech, I just wanted to point out, because I know that we're very close to DC, and it's going to be happening in DC tomorrow night? Thursday night. So anybody who happens to be in DC should go check it out there and definitely support the tour. Okay, so now I didn't have many articles, but I had a lot of maps that I wanted to show you. So this is the must-see section. The first one was actually the Map Lab had a really awesome article the other day. Did anybody see this? About kind of inside what Google is doing. And since we're inside Google, I thought this was appropriate. But a very cool one about how much they're really putting into the effort behind Google Maps and the Google Maps APIs. Very cool article detailing Street View and location and all these things. So really interesting, definitely. And I always have like a little link someplace. It's hidden. It moves around. So you can find that. I've seen a few maps of rats in New York. This is the latest published rat map. Pretty interesting, though, and you can dig around and see which neighborhoods have the most trash on the subway tracks or something. Okay. I always love the building age maps, and this was a really neat one put out of Chicago building age, and you can use the little filter at the top to look at when buildings were constructed in Chicago. The solar eclipse finder, so what you can't tell when I show you this map, I don't have any nice animations in here, but you can highlight any place in the world and find when solar eclipses are happening in that place. So here I've just clicked on New York, and you can see all the solar eclipses that are happening. And there's actually an interface that comes up that I couldn't get a snapshot of that will tell you some more details. Okay, this one's amazing. Does anybody know what this is? You knew it? Okay, all right. I was just looking for maps, and this one was actually made on our tool, which blew my mind. And it's a map of the Star Wars galaxy. Really, really amazing. And do you know some more details about it? Yeah, it has things she has never heard of or seen. Yeah, me neither. Okay. Okay, this one, did anybody see this one? I made this one, so I had to put it up here. This is this was inspired by some maps that were put out of different metro areas by Von Worley, and basically the direction of streets were colored by the direction that they ran. And I did the same thing with all the rivers of the U.S. So you can check out my Twitter profile or something for links to that. Mapbox, Eric Fisher just put these out, maps of 6 billion tweets. I think they said that they were harvesting tweets for the last 3 years to make these maps. Really cool maps locally here. And again, I said I don't have animations, but you could see if I had the animation showing it was the plow trucks moving through Newark, New Jersey. And again, I have the links hidden here, if you can stretch your necks. And that's it. That's all I had for maps right now. So I wanted to turn it over to the speakers, but I'll let Alyssa get back up. And you want to go next, right? Yeah. Okay, cool. I'm going to turn it back to Alyssa, the banter master.
Well, hey, hi. Thank you. Oh, yeah.
Cool, thank you.
Thanks. Thank you, Andrew. Are there any other... Yeah. Before we get started with the speakers and on the first one, do we have any other announcements or news from the audience? Nothing's going on? Nobody's hiring? It's pretty boring.
Yes, I'm hiring.
Oh, somebody's hiring.
Eric Anderson from Bloomberg. So we're hiring for JavaScript, Python, C++, GIS developers. And I always want to say this in public. Oh, by the way, we pay better than Google.
Oh, wow. Bold claim. Okay, Bloomberg is hiring. Large paycheck. Yes.
There's a microphone here. Short arms. Hi, my name's Noel from Beta NYC. Next Wednesday, we're going to host the city CTO, Minerva Tantoko, and we're openly taking questions from the community to ask her about the future of technology in the city. So if you go to Beta NYC, right now we have limited seating capacity at 70, but there's a URL in there that takes you to a Google Doc, and feel free to put in a question, and hopefully that question will be asked next Wednesday. And it will be recorded, and we'll put that up on the Beta NYC website. So thank you.
Yes.
Hi, I just want to, my name is Deborah Solomon. I just want to announce a class which is called Intro to GIS, taking place in downtown Brooklyn at CUNY City Tech. Here's the instructor, Michael Upper. And if anybody's interested in introductory class in GIS programming, I'll be around. So thank you.
Any other? Great. Okay. We'll get started. I'm going to speak. I banter a lot at GeoNYCs, but I've never actually spoken before, so please be nice. I wrote notes. It goes on automatic, the slides. How do I move it forward? Okay. How do I get it to go automatic? I'm here to talk about the community Will it go, will it forward automatically? Thomas, anyone? Yeah. Yeah. Yeah, it's about 5 seconds. Yeah, it's a slideshow in the back. If you can, great, thank you. So yeah, so I banter a lot at GeoNYC, but I've actually never talked, and I'm here to talk about the GeoNYC community and how important it is when we are like sharing ideas and talking about the city, how important you are to me and how important you are to each other. So for those of you who come regularly, you might be asking yourself, or have asked yourself at some point, where I've been these past 2 months. And I say this is a good question, possibly a bantering question, and this is where I've been. So 2 months ago to the day, on October 9th, I was in West Virginia, of all places, on a bike trip when, yeah, I don't really know what happened. I don't remember. I don't have a map of it. Social media was not there. I don't really have witnesses. And so my next memory is on the 21st, over 10 days later, in New Jersey. I was watching the Planet Channel with some friends. One of them's here right now. I remember the hashtag Cutathon, and that's what happened. And so I was on a bike trip. I fell, and the diagnosis was pretty unbelievable. In addition to the broken memory, I had broken or fractured my neck, and I got what is nicknamed a TBI, or more dramatically called a traumatic brain injury. So I woke up and immediately went back to sleep, hoping that my real life would return, because this new one was unfamiliar and painful, had bad service, poor food, didn't make much sense. But there was something with me that helped usher me through this time. And I mean this with the most sincere gratitude and appreciation and love. You guys were with me and helped me in this process of recovery. So when I could finally see and when I could make memories, I would look at the number of flowers that I got, the number of cards, the people who came by and talked to me, the emails that I received, thousands of them. You made a real difference. You made a real difference to me. You made a real difference to my family. And so this is the first time that I understood why taking a moment to do that extra thing, go the extra mile, really makes a difference. So this is a sincere thank you. And you'll see some pictures of some of those cards and flowers later. So I'm back. I'm back at GeoNYC. I'm not back 100%, but I'm back, and I have a community. I have you guys to return to, and that means a lot. And you have been very present in my recovery and very meaningful in the healing. And if we take a step back, and I put like a fancy word on what this phenomenon is, I'm going to recall it a convening event. I didn't know exactly what it meant to be a community. I didn't know that we were a community. I didn't really call ourselves that. But I don't think we had been tested. But you convened around me at a really important time, and you made a difference. And you took that extra time, that extra moment to make a difference. And so if I talk more about what this community is, it's not only awesome people who send great cards and emails and just come visit me, but I think we're a community that's trying to understand the world, understand our city, and we'll talk more about that today. How we relate to it, how we tell stories about it. Simply stated, we are a community that cares about how and why and what we map and understand the world. And so we have another event that's coming up, one that's full of the collaboration of New York City, one that's also a convening event that is much happier than a bike accident, and that is we'll be hosting, New York City and the UN will be hosting the next OpenStreetMap conference in June, from June 6th to 8th at the United Nations. This is huge. And we have many people here that can help, that people here from the UN, people here from the OpenStreetMap community, people here from organizations and community members that are all working on it. So this is huge for open mapping, but it's also huge for us as a community. We have the opportunity to come together and show the world that what it means to support each other, to map a bright future. So I encourage you all to get involved. There's a URL way further back, so maybe, yeah, this is the happy stuff. So I encourage you to get involved, to sponsor, to volunteer, to sign up. There's like a URL later in the day. Come see me later. And there's other people here from the UN, Lambert, Janice, Colin, Andrew, Eric, Randy, Liz. All these people are involved in State of the Map. Please come and see us and get involved. And I think it's a great opportunity to like pull that energy that we have from GeoNYC and put it into a really exciting and convening event. So thank you for everything. Thank you for your care and concern and love. Thank you for being here. And thank you for your help as I was getting better. And I hope that we can take that energy and move it towards a really great conference. So thank you.
Quick question, could you repeat when the OpenStreetMap conference is?
Yes, it's June 6th through 8th at the United Nations in the huge General Assembly.
And
So
if people want to get involved, is there a hashtag or what should
yes,
they do?
if we go through these flowers, blah, blah, blah. Sorry, you guys gave me so much, so it's have to go through, blah, blah, blah. Yeah, that's there. There were Legos involved, that's United Nations, and here we go. So this is the bit.ly link if you want to get involved in the newsletter for updates. But come see us or somebody from the OpenStreetMap community if you're interested. And we'll continue to update you on the progress while we're here. Like here at GeoNYC.
Do we have another question for Alyssa, or we can move on to the next speaker?
Awesome. Thanks. Thank you. So our next speaker is Sarah Kaufman. She is a researcher at NYU and is going to be talking about, yeah, you kind of have to keep going through these. Wait, oh, I can do that. Yeah, this is what the conference will look like. Et cetera, et cetera. I'll move through. But this is Sarah Kaufman. She is a researcher at NYU and will be talking about transit. And do you want to take it away? And I'll get to the next stage.
It really is bright. Hi, everyone. I'm Sarah Kaufman. I'm here from the NYU Rudin Center for Transportation. While Alyssa's forwarding the slides, I will say welcome back. Thank you. And tell you about the Rudin Center, which is a place where we are always on the cutting edge of looking at transportation and technology and policy. We like to think unusually about different things in New York City and how cities work, especially vehicle shares, supercommuters, and as I'm going to talk about tonight, job access and mobility. And you can reach us at nyurudincenter.com. So, but tonight I'm going to talk about a report that is, I'd say 80% complete, about job access and mobility, or basically how people get to work and how their transportation to their employment affects their economic standing. So, in study after study, New York City, bless you, is #1 in transit access to employment. Study after study, we're #1. So you had a wet, delayed commute this morning. Well, on average, your commute was better than someone on the Chicago L this morning. That's on average. But the fact is that New York City is a city of neighborhoods, and the average does not represent the whole. So at the Rudin Center, we divided up the city into its 177 neighborhoods. As you can see, as you know, and as you can see from these photos, it's a wide variety, and some people have very short commutes, and some people have very long commutes. And so we looked at it compared to household income. And so you can see by borough, it's broken down, and what's not surprising is the Manhattan factor, which is that the neighborhoods with the simplest job access That's the shortest commute by transit or walking to their jobs. The top 22 are in Manhattan. We ranked all of the neighborhoods, all 177 neighborhoods, by the number of jobs they can reach within 1 hour. The multiple studies have shown that people don't want to travel more than 1 hour. They would prefer not to. And so we calculated how many jobs people could reach within 1 hour. Now, that's an important factor because the more jobs that people can reach within a given time frame, the more opportunities they have for career advancement, and their unemployment periods will be shorter. So as I said, the report isn't complete, so you have to kind of flip your perspective. So if on the lower axis, on the x-axis, you have the neighborhood ranks, number 1 being the most accessible jobs. So what's interesting is not that what you would think, that the neighborhoods with the worst access have the lowest incomes, but actually, let's call it the middle third, has the lowest income. These are people with some transit access. Usually they live near one subway line. Often they have to transfer en route. The lowest third often has to take a bus to a subway. So what's interesting is that this middle third also has the highest rates of unemployment. And why does the lowest third not suffer as much? Because they're driving. They're driving to work. They're not taking transit like the top third and the middle third. And the top third is often walking, actually. So what did we do? We made a map, which is why I was invited. And the map was created by Jeff Verzocco and Richard Dunks, who's out in the audience. Say hi, Richard. The map was created in D3, and Richard can answer all your questions about D3. So I'm not going to share the link to the map yet because we're still revising it. And actually, this isn't even the most current form. But the idea is that you can click on a neighborhood, you can find out the demographic and employment and transportation data for that neighborhood. We would like for activists and the public and policymakers to use this map to better understand the landscape of New York City's commutes and how, on average, we're doing great, but that's not so throughout the city. So we're still getting this together, and you'll see it within the month online. And I'll share the link with the organizers. In the meantime, I have some solutions to these problems, or I'm proposing some solutions. And mostly it focuses around infrastructure creatively, infrastructure being a verb. Let's infrastructure creatively. Let's implement an intelligent bus service. Basically, if Uber and a dollar van had a baby, let's do that. So if you take a van, if you have a van pool, on-demand commuting for neighborhoods that lack transit but are just kind of a short trip to a transit hub. And one that I like to think about is Red Hook. So Red Hook is kind of a transit desert in a way. But if you implemented a straight shot from Red Hook to downtown Brooklyn, where we know so many subway lines collide, you would give them access to about 2.5 million jobs in addition to what they already have, which is less than 500,000. And that's in under an hour. So it would be a powerful resource for them. The next is bus rapid transit, as so many groups have proposed before. Why aren't we using our wide boulevards in the outer boroughs, in particular East New York South, which has very little transit access? If we implemented bus rapid transit on Woodhaven Boulevard, which is a popular proposal, we could give the residents of East New York access to jobs in Midtown Manhattan, over 1 million jobs added to their original job access within an hour. And as you can see, in East New York, it's very hard to reach anywhere within an hour. we should be maximizing the existing transit system. What people don't talk about is that there are some sections of dormant track. Like in the Bronx, there's some express lines that were kind of shut down during budget cuts and should be reinstated. There's a 5 express line that goes to Norwood in the Bronx. It's time that we get express service for people in the Bronx to get them kind of a leg up on getting around the city. And there are also some simpler transit connections that should be made in the outer boroughs. There are a lot of transit lines that end close to each other but don't have transfers. Building those transfers is cheaper than like a day of building the 2nd Avenue subway. So it's time to do that. And finally, we should start incentivizing remote work. From a policy standpoint, New York City is full of people who have jobs where they can work remotely. We have a robust library system. We have office shares. We have people who would love to avoid the commute headaches. And we are at overcapacity on a lot of subway lines. So it's time to let people start working remotely. So in short, we need to infrastructure creatively. We need to let people commute so they can improve where they stand. So I encourage you to check out NYURudinCenter.com, and within the month, you'll see the report and map live. And let me know if you have any questions. Thank you.
Hello. Are there any questions? Go. Yeah. Yeah. Oh. So active. Go ahead, JD.
So I'm wondering if you took a look at the quality of jobs that were available to people as opposed to just total jobs.
Yes. If anyone didn't hear, the question was about quality of jobs. So we did break down by job type that was available, and when the map goes live, you can see the top 5 job types that are available from each zip code to destinations. And also, I'll scroll back to, you can see the number of residents who have high school diplomas only have access to X number of jobs, because that's an important factor. If you send everyone from one area where people are limited to high school diplomas and you send them all to Wall Street, they won't function, they won't be hired very easily.
Do we have one more question on the table? Yeah?
Are the numbers updated? The numbers are fixed. They are from the Department of Labor. So I imagine we'll update it when their new numbers come out, but I believe that's annually.
Whoa, who's this person?
Oh, this is Richard.
Hi, I'm Richard. So the jobs that we... I can't tell you about D3. It sucks. No, it's wonderful. It's great. Wonderful. I love it. Thank you, Mike Bostock. No, so the jobs numbers are from the 2011. It's the loads data from the census. So that data set is updated. I think it's every 4 years or so. The demographics data is from the ACS. It was a 5-year survey, and that's obviously this is the 2012. It's 2008 through 2012. They aggregated them together. So yes, it's updated-ish, but still, it's the lagging of the data sets. So.
Great. Next up, I think he's running to the stage. Is he? No more questions. No, I think. If there are more questions, come visit later. We have so many speakers. But Colin Reilly, he heads NYC Do It, the GIS. Do you want to take it away?
Sure, I will. I was expecting quite a different setup here, and if you haven't heard already, it's really bright up here. All right, so you can all hear me? And I thought I would see my notes because I kind of had to put this together at the last minute. So anyway, bear with me, everyone. And if I'm running over, please let me know. I can't see you, so hopefully you can see me. All right, so I was asked to speak at this talk, and this is a sort of lofty presentation I came up with. And I should qualify this with stating that there are no maps involved in this mapping discussion or this mapping themed discussion, right? And it seems to be a common theme with me. I do have a few photographs, but there are no maps, so I apologize for that up front. So my email address, if you need to get a hold of me, my Twitter handle, if you want to tweet about things or complain about me in social media. So anyway, I was trying to come up with a topic for tonight's talk, and I didn't want to do something I'd previously done. So the first thing I did was I looked at what the theme of today's talks were supposed to be. And what you see on screen, it was what it was, right? So open technology tools for city government. And as often the case, I'm one of the few city government folks that attends these events. I know Jackie's here as well, which is good to see. So I didn't really want to bore you all with defining what I think the requirements should be for those developing tools for city government. Maybe we'll do that another time. So anyway, what I came up with is what I'm presenting to you. But it wouldn't be government without a disclaimer. So my disclaimer is up here. These are my views, opinions, and ideas, not my employer's. So you can blame me. You can't blame my employer. And if I didn't mention that, or if Alyssa failed to mention that one, I work for New York City Department of Information Technology and Telecommunications, effectively known or affectionately known as DO-IT. Right. So I wanted to give a sense of where we are in terms of geospatial technology within primarily city government. But first, to understand where we are right now, I thought it would be interesting to take a walk down memory lane. So we're about to do an historical perspective on GIS, or geospatial technologies, and you'll have to excuse me if I occasionally slip to my my notes just to make sure I don't forget anything. So anyhow, what I will say is that I am very there's a deep connection between myself and GIS. And this may be a bit of revisionist history, but I postulate that the above photo, which is of me, is me sticking my finger in the first GIS day cake. And I've managed to do that every year since. But all kidding aside, we're both children of the 60s. I'm a bit later in the decade than GIS. But so the connection begins in the 60s, where really GIS started. I was a product of my parents. GIS was a product of problem solving. You had natural resource managers, you had planners, demographers, and the like, trying to figure out how to manage, update, and analyze, which was essentially paper map data. The advent of computers, a few bright minds had some really great ideas, most notably Harvard and the Canada Land Inventory, which was to model geospatial data in a computer. And in terms of data at that point in time, it was all about how do we model this data and how do we structure to store it in a computer. So that was the 60s. Fast forward 10 years, and I've let my hair grow a little bit, and I told you this was very much a personal story here. And the government followed suit. Forward-thinking people, some may consider them hippies, started developing and funding what was at that point in time called public domain software. And you had things like MOS and View It, which was a viewshed analysis package. MOS was one of the first GIS packages was developed. Were all funded and or developed by different agencies within the US federal government. And then you also had Landsat first launch, also a government initiative. So we're starting to see a common thread here, which started first recording some of the first imagery of the planet we call home. So then, let's go another 10 years down the line. And by the by the 80s, I'm getting a little ahead of myself here, I'd seen London Calling on a show called The Midnight Special. And that was a show, it was midnight, as you might suspect, pre-MTV, and it sort of changed my life. So I cut my hair, decided I was going to go to college, and start getting serious about my life. And I think the US government might have done the same thing, or started to at least do the same thing. You had GRASS, which was really the first public domain software released, once again, by the government. And then in academia, you had Dana Tomlin releasing, in a paper, the essential ingredients for raster analysis, which was map algebra. He didn't copyright this. This was a paper he had written, a scientific study, and he shared that with everyone. And GRASS used map algebra, ArcInfo from Esri used that. He received no royalties from that. And then you had the US Census, another government entity, releasing Tiger, which was essentially the first large-scale release of open data. I hope you're all history buffs over there. And those of you who are classically trained GIS professionals, I'm sorry if I'm boring you with some of this history. Anyway, next up, the next decade, the 1990s. So I decided to grow a beard, and I took a long, long trip. I spent almost 2 years in Asia. And I think at the same time, the US government started its long trip as well. It started to stray away from public domain or open source software. And if anybody can recognize this, this is actually at the Khyber Pass in Pakistan overlooking Afghanistan, for those of you who are interested in the photograph. So what was happening in terms of GIS in the 90s? You really had the rise of commercial GIS. Prior to that, it was governments funding the initiatives. It was academia looking at it. If I would characterize the 90s, it was really the commercial rise of GIS. And that's when ArcView, the first real desktop, GIS package took off, at least the first GUI-based desktop GIS package. And the ubiquitous shapefile, which we all love and hate, which came out of the 90s and is still with us. And then in terms of academia, people were already grappling with the concept of geographic information systems. That's not really a term I really like. It doesn't really describe exactly what I'm doing. And it's funny when I think about all the people talking about it right now, it actually started, at least in academia back in the 90s, and it was termed geographic information science. And you started to see GIS, and that's when I first started studying it, sprouting up in planning classes, environmental study classes, and so on and so forth. So then let's fast forward to the year 2000. I guess I look a little more like that photo than I did in some of the previous ones. So I shaved my beard, I bought a suit, and I got a job with New York City Do It. Finally, I realized my dream of getting serious in life, right? And at the same time, Google bought Keyhole and exploded onto the scenes. And if there's really any one event, if I think about it in terms of bringing maps to the public, it was Google Maps, right? Everything else paled in comparison to that. I could now go to parties and talk to people and say, wow, what do you do for a living? I do something kind of similar to what they do with Google Maps. Oh, it made sense to people. Previously, when I had explained things, it all looked at me as if I had the sort of three heads. Anyhow, open source sort of takes off. You've got PostGIS, you've got QGIS, you've got UDIG, you've got the like. And I'd be remiss without mentioning the fact that this is when OpenStreetMap first launched. And with the idea when, okay, if the Ordnance Survey is not going to make its maps or its data available, then we'll go ahead and map the world. And 14, nearly 15 years later, people are still doing it. And as Alyssa had said, we're hosting the conference this year. So if you haven't already registered, if you're not thinking of registering, you should. And then, of course, KML, which is really the first ultra-portable geospatial format came out. So then here we are, the 2010s, right? And that's me competing in the Lehigh Valley Marathon. It's probably towards the end of the race. And it kind of brings back to me the fact that this technology, this profession, making maps, geospatial technology, is also like a marathon. Of course, it's not as close to the finish line as I was. There's a lot of changes that are happening right now. What I'm seeing is the democratization of web mapping. I'm seeing things like CartoDB, Mapbox, MapZen sprout up, and addressing a lot of the needs that previously weren't addressed or were taken advantage or, you know, were assumed to be accounted for in previous software attempts. And really, it's all about putting the technology in more people's hands to do sort of mapping and spatial analysis. And I'm not sure I've coined that term, but anyway, I shall use it. And it's the big open data movement, right? If you could characterize 2010, it's certainly about opening up government data. You saw it started with apps for democracy, and it spread nearly across the US and the globe for that matter. And with this, you're seeing a lot of disruption in the market, right? There's a flood of data out there, and people are not sure of what to make sense of that. There's a lot more products out there. So really, I'm seeing a lot of change in the marketplace, which I see as a very good thing. So I'm very excited for 2020. Hopefully I'll make it to it. So sort of to summarize things, with respect to government, I think we've transitioned from being a producer to a consumer. The large vendors of the world will probably be happy about that. With respect to data, I'm also seeing governments also begin to become more of data consumers as opposed to just data producers. You know, the expectations have changed with the democratization of mapping. The expectation now is not build me an app, it's make your data available. Or if you're going to build an authoritative app, make sure you make that data available as well. But essentially, it's still about data. It's about analyzing that data, and it's about producing products from that data, which are maps, right? But if I would add my 2 cents, I think we need more independence, and we need more innovation in governments. And by innovation, I don't mean necessarily writing software, but using the tools that are out there to help solve the problems in innovative ways, as Sarah had sort of addressed in her presentation previously. So, has anybody taken a chemistry class? Okay. Anybody know the term free radicals? I'm not talking about the crazy people in the 1960s who were shouting out for something completely different than the government had to offer them at that point in time. A free radical is, and I'm quoting here right now, and this one I'm going to have to read, right, because it's been a long time since I've taken chemistry, is any atom or molecule that has a single unpaired electron in an outer shell. And while a few free radicals are non-chemically reactive, most are highly reactive. And I bring that up because I just wanted to say that software really shouldn't be, one, reactive. And open source is not free, and it's certainly not run or developed by a bunch of radicals, right? So you're all supposed to laugh right then and there or say, oh, what, you know. At least I will. If you can't laugh at your own jokes, I mean, come on. Anyhow, so if you are making software decisions, you should certainly consider open source software. And if you're a vendor out there wanting to do work with city government, and you have a resistance for using software that is potentially open source or is open source, then you should rethink things. So anyway, it brings me to the final topic of what is the role of government, right? I'm not proposing that we should go out, turn back the clock, and start, you know, writing open source software. And I guess, you know, the answer you would receive would be dependent on who you ask that question. If it's the big vendors of the world, they'd say, oh, let's leave things the way they are. Let's leave it at status quo. We'll sell government really expensive software that occasionally works. Sometimes it doesn't. And everything will be great. Or maybe government needs to take a more active role in developing open source software, right? You know, if I think of some of the different, you know, disciplines within software, asset management, for instance, if you just, you know, cobble together some of the different cities out there that are funding the same initiatives repeatedly, maybe if they banded together, and did things a little collaboratively with, obviously, community support, things might be a little better. My next slide, we're all familiar with NPR, right? So, and that coexists with commercial radio companies, right? Communications companies. There's a National Science Foundation which funds scientific research. Why not have a national open source foundation where governments, again, fund open source initiatives? Maybe they don't own them, but they fund them, they support them. Just throwing that out there. Once again, I refer you all back to the disclaimer. These are my ideas, right? Not my employer. Anyway, to close it all out, we are hiring at Do It. So I didn't want to say that in the beginning when you asked me, because then I would have stolen my thunder. But the URL is right there. We're looking for a spatial database administrator, someone who knows PostGIS. And with that, I'll end it. Take a few questions.
Any questions? Cool. Thank you.
All right. What was that? Do I tie in with USGS? In what respect? No, I mean, USGS is at the federal level. I'm at city government level, so no, there is no tie-in with USGS. Yeah, what was that? Sorry. Maybe I missed the question.
Oh, sorry. Yeah, USGS can be part of the National Open Source Foundation that we're starting.
They can provide funding for my initiatives.
Yes, exactly. Exactly. So open to funding. Okay, next speaker. Thank you, Colin. Next speaker, he's from Kansas originally, Josh Campbell. Where are you, Josh? So bright. There we are. He's coming in from DC and speaking from Boundless about editing software. Go ahead.
All right, thank you. Thank you very much. It's my first time here. Very, very excited to be here. My name is Joshua Campbell. I'm here to tell you that spatial data has a problem. And I think anybody who's worked with spatial data for a long time will have, or for any time, will know that there are definitely issues associated with keeping data up to date, managing it, sharing it out, understanding its lineage, understanding its history. And since we just had a history lesson, I think we can contextualize this a little bit by saying, 10 years ago with the advent of Web 2.0, everything that we started to do online took on a social aspect, the ability to share out and go from like a one-way publishing model into a two-way kind of conversation. Well, I would argue that spatial data is a Web 2.0 orphan, that it was left behind. And so we've had a decade of spatial data infrastructure and spatial data catalogs that are very static and very much, I have data, there you go, do something with it. Wish we could talk about it, wish we could do something, but we can't. So I'm going to present to you a technology that we at Boundless have been working on and turning that into a platform. The examples in here is kind of how teams might operate to map electrical poles, right? Well, that could be anything. That could be any sort of open data set. And that could be not just an internal team, but a mix of an internal team and external team, or something going all the way to the end of the spectrum, could be the crowd. Right? So we could be thinking about this as an idea of how you can take open data, publish it out, allow the crowd to edit it, and not just do that in a one-way process, but be able to pull those edits back in and enrich authoritative data. So I work for a company called Boundless. Website's boundlessgeo.com, and you can find the new product it's called Versio at verse.io. We're in private beta, so you can sign up for access if you're interested. So what are the problems that you have with spatial data? So current workflows make it difficult for teams to work together on data. Editing data, staying organized. Even if you're a one-person shop and doing spatial analysis, you can lose track of things. And then understanding the lineage of your data. How many times you have test result 1 and test result 2 of your shapefiles. So in terms of synchronous edits, how do you handle things that are off-site or with these other parties that maybe you have less trust in? How do you handle third-party contributors? That's that kind of crowd idea. And how can you have lots of people working together? Staying organized. Again, getting this folder full of files that start to, at some point, lose the reference to each other. You can't understand how one led to the other, and it just comes up with, if you do it well because you just impose upon yourself a very rigorous way to manage your data. It's not easy. And then this idea of a living history. Oversight in a regulatory framework, or just being able to keep optics on what's happening in your world. So we looked at for inspiration, we looked at another place where these problems occur, and that's in software. So we took the analogy of what distributed version control systems did for software and tried to apply that to spatial data. So think of it as analogy, what Git, the open source library, is to GitHub. We are working on an open source library that's part of Location Tech called GeoGig, and now a new platform around that called Versio. And what we're trying to do is unlock the power of GeoGig for broad team collaboration. So if you're interested in GeoGig, you can go out and get it. Free and open source, under a BSD license, part of Location Tech, inspired by Git. Now this is, for the software people, if people use Git, they get this really quickly. Spatial data people, GIS people, it's a bit of a learning curve. You got to think about repositories, words like branching, forking, merging, concepts that we haven't applied in traditional geographic information science. So here's Versio. Again, we're in private beta. This URL is live. And basically what we're just trying to do is take what GeoGig is and what you can have locally and build that for web scale. So how do you put a high-performance server on it and put it on an enterprise database and make it big and bulky and powerful? So I should say the website, right now, the website acts as a repository. Currently, we support QGIS as the editing platform, and there are various other editors coming, primarily for ArcGIS, mobile, and online. But right now, if you're interested, it's better if you're familiar with QGIS already. So let's look at a simple collaboration model. So in this case, Eva just wants to share out data sets. She can push that into Versio, and Matt and Ben can come along, make clones of that data, fork it, do whatever they want, check it back in, and Eva is updated automatically. Very simple. Also something you can't do with current technology. Let's take that into a little bit more complex workflow, where you've got maybe a department head or someone that needs to keep oversight. Now Ada is responsible for managing a team, and then you've got remote collectors. In this case, we can think of Matt and Ben as kind of the crowd, right? So that could be 1,000 people right there. So again, Ada takes the data file, publishes it to Versio. Matt and Ben come in, make clones of it. They can go out and make edits independently. And because it's fully distributed, they have a full local copy. They don't have to be connected. They can do this offline. And when they get back to connectivity, they can push those edits back up. They can make edits independent of each other. And then when they get pushed back into Versio, they come in as different branches or different forks. Then Ada can look at each conflict between those data sets and approve or disprove the edits that go in. Then at the end of this, that entire audit log, that entire commit log is present in the data. So each one of these versions that gets checked in with a message. So the department head at any point can look in, see who's doing what, keep eyes on it. So if we look at a sample workflow over time, it's just another kind of way to look at this, kind of inspired by the Git diagrams. Ada publishes a repository, that gets forked. Ben and Matt can make changes as they want. They check those back in. Ada can then resolve those changes and then push those back up, and Maria can look at those at any point. Now, I think this is going to have tremendous impact for team collaboration, but I think this could do even more in the open data world. I think when I think about authoritative data sets and and the resources that governments are spending to maintain their data sets, to be able to leverage the power of the crowd in a way that governments can utilize the data that comes back in. It's one of the fundamental issues with, I'm a huge proponent of OpenStreetMap, but the licensing issue gets kind of dicey. So I think this is a mechanism by which the crowd can contribute, enrich open data, which then can be republished out for consumption in OpenStreetMap or anything else downstream. So with that, I'd just like to say thank you very much and remind you that spatial data has a problem. Happy to take any questions. If there's a couple over here, maybe.
If you want to just come up to the microphone in the between the rows of seats.
So this sounds great. I mean, and it looks like it'll work really well for small changes. But what about something like the road network, where you have a huge tangled mess of things that are all connected to each other, and if you want to change those, it seems like it would be harder to make a change to just one thing like that.
So I think maybe so like if you have a road network or something where things are topologically linked, right, and it's a complex data structure, I would argue that first of all that's a hard thing to edit in any toolkit, and then in this case the question is going to be someone takes it and makes edits. The question is really, did they break it? So then your conflict resolution and detection and the tools that you have to re-snap things, a lot of that gets pushed out of the kind of like data repo tier and really into the editing environment, either in QGIS or ArcGIS or the website, and the rigor of the editing rules that you have to have in place. We believe that in a lot of use cases here, you're going to have very customized rules that need to be employed, both at the workflow level and at the data tolerance level. And those are going to have to be coded for in order to make it a seamless process. I'm not going to say that this is a silver bullet, that it's going to make, a very complex process just immediately easier, but it will give you a tool that we've never had before to actually do it.
Hi. Two questions. One quick one. So you said you can use QGIS, or there's some other tools coming as an editor. So that means you actually can visualize the pull requests, commits, compare them visually before you approve.
Yeah. So you'll have all that functionality in the client itself. Like QGIS has diff viewers and the editing tools. But in Versio itself right now, when you check in new versions, you get the full commit history, and you can visualize every commit that's made independently. You can compare any two commits in the chain. So if you've got 100, you can be like, I want this one and this one. And we have a diff viewer and an overlay viewer so that you can see what features were added, changed, modified, both spatially and in the attribute tables, so that you can quickly begin to understand what changed between the two. And then the final step is you have to have some tool that says, okay, you gave me data, it's contradictory, I've got to decide, or maybe they're both correct, maybe your geometry is correct and your attribute's correct. I have to have a way to bring those both together and check those in. And I want to know that you provided the geometry and you provided the attributes. So right now, QGIS does the bulk of that heavy lifting in terms of the merging, but as we continue to develop, those functions will flow into the web tier.
Thank you. The second question is, are you preserving the format that the data originates in, or are you coercing it to a different internal format? Yeah,
you basically can, it's import and export are theoretically constrained by the OGR library. Okay, so any data input that you want, that QGIS can read it, it then takes that format and it pushes it into Versio. And so the repo has its own unique data structure. In theory, you can then export out to any format that you want. Right now, we're focusing on shapefile and GeoJSON and PostGIS tables as your exports, but in theory, we should be able to support any of them. And as well as it keeps the data in its native projection in the database. So if you have very high precision projections, like state planes or survey grade data, you should be able to maintain the precision of that data in the editing environment.
I see there are other questions. We're going to put them towards the end. Yeah, so I encourage you to come up and stay afterwards and continue talking. Our next speaker is Robert Cheatham, coming from Philadelphia. Thank you very much. Who here has a tree in front of their house? Nobody. Wow, it's like the educational setup. So he'll be talking about our urban ecology and open tree map. Yeah?
Yeah.
So please take it away, Robert.
Thanks so much. It is really bright up here. I think everyone said that. I'm visiting from Philadelphia, so thank you for the opportunity to come up and visit with all of you. We also have a GeoPhilly meetup, and you are all invited. It's a short train ride down to Philadelphia. I'm excited to be visiting our northern suburb up here. I got that. So. You should come into the city more. So I'm going to talk about an open source project that my organization, Azavia, has been working on for several years. Alyssa said we should do this in 10 minutes, so I'm going to try and get through this pretty quickly. But talk a little bit about where it came from and how this kind of work, urban forestry work, relates a little bit to New York City. And then there's going to be a related talk right after this where you get to hear some more details about that. So OpenTreeMap, before I get into that, I'm from Azavia. We're what's known as a B Corporation. I probably won't be able to see it, but how many people have actually know what a B Corporation is? Wow, that's like the most people I have ever seen in any audience that know what a B Corporation is. So we're a B Corporation. The B stands for benefit. B Corporations are a new kind of company. It's a legal form in New York State as well as in Pennsylvania and other places. About 30 states now have this corporate form. It's a bit of a cross between a for-profit and a nonprofit organization. We're a for. We are benefit. That's right. That's right. We are a for-profit company, and we are both a benefit corporation and a certified B Corporation. So we work on, that gets exemplified in a number of different ways. We operate with a social mission. All of our projects have some kind of social or civic impact component. We do a lot of research work, and we also run programs like Summer of Maps, where we provide fellowships to students to work with nonprofit organizations, and we do a lot of open source and open data work. So that's where this comes from, and a lot of our work relates to land, water, and people in some way. So I'm going to talk about a couple of aspects of that, land and water. Trees. Trees are a wonderful thing. We all love trees. They make our streets more beautiful. They raise the real estate values of our homes. But they also do lots of important things around water. This is a map of Philadelphia's historic streams. This is where the streams generally, where we think they were a couple of hundred years ago. This is where the remaining open streams are today. And all of those, a lot like New York City, got buried into sewers and got turned into storm sewers. And that turned into combined sewers. The storm and the sanitary sewers were combined in the same pipes in a lot of our old East Coast cities in America. And that has created a combined sewer overflow problem. New York and Philadelphia both share this, as a lot of other big cities do. Trees are not only make our streets more beautiful, they infiltrate water and catch it before it goes into these into the gray infrastructure. They also, as you all know, sequester carbon. They save energy. They shade our homes if they're planted near a building, and reduce electrical usage. They also, many of them, increase species diversity. They obviously provide habitat for birds and other critters. In many cases, they improve our air quality. In the United States, more than 80% of us live in some kind of urban area. That's about 240 million people. There are 100 million acres of urban forest land in the United States. It's a huge, huge number. And that translates into about 650 million urban street trees. Many of our communities don't have all of the resources required to take care of all those trees. And at the same time, there are lots of people who are very passionate about caring for them. That engaged citizenry wants to see the street trees thrive and be successful and grow over time. So we had an idea for a project several years ago that would bring those two groups together, municipal or county governments that want to take better care of their trees and want to get better information about them and the benefits that they provide to their communities, and members of the public. So we applied for a grant with USDA under a program called the Small Business Innovation Research Grant Program. And we were so excited in April a few years ago when we were told, you are the winner. And then like a week later, this really great project gets released in San Francisco called Urban Forest Map. We haven't even started the project. We're like 4 months away from actually getting our money and doing this. And it was a really, really slick project. And they were going to release it under an open source license. And we're like, we just got this money. We're going to build this really great thing. And someone else did it. So rather than build a different rival project, we got in touch with these folks, and they were really terrific. They said, sure, some of the stuff you were going to try to do were things we wanted to do and didn't have the resources for, and let's join forces. So our East Coast team in Philadelphia joined up with the San Francisco team, a group called Urban Ecos, and which is a consulting firm that does urban ecosystem, urban ecology work, led by Kelaine Vargas. So we all got together and worked, began to basically turn this into a much more generic platform, rebranded it as Open Tree Map, and released it under an open source license about 6 months later. Fast forward several years, well, not several, a few years, 3 years probably, to where we are today. This is now both a cloud platform, very similar to GeoGig and Versio. There's an open source platform that's there for anyone to implement their own tree map for their community, as well as a cloud platform that people can subscribe to. And it's got interactive maps with lots of different search features, and it's not just an inventory, though. It computes ecosystem benefits that each tree provides. So what is the dollar value of energy conserved, of stormwater filtered, air quality improvements, carbon sequestration, and so on. And that can be done at individual tree level as well as aggregated for a neighborhood or for an entire city. Every tree gets its own sort of Facebook page. It's a profile page. You can upload photos for it and add lots of other information for it. And there's a lot of opportunities here for citizen engagement. There are probably about 12.5 communities around North America that are using OpenTreeMap at this point, and they do things like mapping parties and teach people about species identification and how to measure diameter at breast height. The two key values that we need to calculate those ecosystem services benefits are species name and the diameter of the tree at breast height. And so we have videos online for how to learn how to do that. And you're going to hear some really great stuff about measuring where trees are in the next talk. There's also an iOS and Android version for this, also all open sourced and available for you. We're just starting to extend this in Los Angeles to not just be around trees, but other so-called green stormwater infrastructure, things like rain gardens and green roofs. And this is just being has just been rolled out recently. We also are doing some follow-on research work around prioritization and simulation, so helping communities figure out if air quality is our biggest concern or stormwater is our biggest concern, where should the next 100 trees go to alleviate those things? Or if we plant trees in these locations, what are the ecosystem benefits going to be at 5, 10, 15, 20, 25 years? So this is pretty exciting. There's a map of some of the tree maps around the world. We've got India and the UK, a couple of Canadian cities, as well as a number in the United States. We love our open source tools. The platform is built largely on top of open source components, Python and Leaflet, and we use some CartoDB components, PostGIS, and so on. GeoTrellis, which is a location tech project that was mentioned earlier, is helping do that ecosystem services computation. This is a distributed geoprocessing platform, and it powers that simulation and prioritization modeling work that I just mentioned. And we've had just incredible partners over the years that have helped us build this out and improve it and given us feedback and told us we're full of it when we are, and given us great suggestions. And you're all invited to participate as well. You'll be hearing a little bit from TreeKit just after this. And we all want your help too. You're invited. There's 650 million trees to map, and it's time to get started. There's lots of things that you can do if you're a developer or designer. to help improve OpenTreeMap itself, we are looking to add features around gamification, making it more fun to do this kind of inventory work, adding custom symbology, team management, APIs. We have a lot of interest overseas, and so there's some need around language translation. Here are some ways that you can get involved with OpenTreeMap. There's a mailing list, website, GitHub repo, and so on. And utterly unrelated to OpenTreeMap, you all are going to experience a once-in-a-decade event called the New York City Tree Count 2015. And I bet the two people that follow me are going to talk more about that. But even if you're just into getting involved in local things in your community and helping out trees, this is going to be an amazing opportunity next summer. So I'm pretty excited because this is a way for GIS and maps to really encourage transformation of our cities into much more green and pleasant places to be. And that's all about OpenTreeMap. Thanks very much. You are all invited. 650 million trees to go.
Are you active in New York at all, or are there other tools here?
Is Azavia active in New York?
That's a great question.
Or is OpenTreeMap? Oh, as far as I know, I actually don't know the answer to that. I mean, it's an open source project, so there may be people using it here, and we wouldn't know it. I don't know of any public maps that are up and running in New York City. There are some terrific. Gowanus Canal. Absolutely. There is an OpenTreeMap instance here. Gowanus Canal Conservancy has one. There are trees in the area around Gowanus Canal, and there are also some really interesting things that the Gowanus Canal Conservancy would like to do around rain gardens and bioswales and that sort of thing. So thank you. Sorry. Thanks for correcting me. Are there others outside of that? The city is not using OpenTreeMap as far as I know, but they are going to be building software around this tree count effort, and maybe you'll hear a little bit about that with the next speakers. All right, thanks so much.
Thank you, Robert. So our next speakers on this topic of trees, we have Liz Berry and Jackie Liu. Jackie Liu heads GIS at the New York City Parks Department. Liz Berry is the co-founder of TreeKit and part of Public Labs. And we're going to be starting to count our trees. Is that right?
That's right.
That's right.
That's right. This is the,
Finally.
This is the not my own opinion government talk. This is officially sanctioned. So hang on, I need to juggle clickers and slides, and Liz and I, we both have our, toys. So I'm Jackie.
I'm Liz.
And we're here today to talk about how New York City Parks, together with our partners like TreeKit, are going to, in 2015, use neighborhood-based participatory mapping to precisely and accurately inventory and map all the trees that are planted in the public right-of-way across the 5 boroughs. Our goal is to use that data to directly support and improve the way Parks operates, and we also hope to use that data to support the efforts of our tireless more than 15,000 tree stewards and volunteers that are out there. So now I need to switch this. So in case anyone needed a reminder, trees are these amazing multitaskers that provide a myriad of benefits and make the city a better place to live. In particular, our street trees. They soften the gray, hard infrastructure of our urban landscape. They're essential to the character of our neighborhoods. And our best guess at the moment, at least until next year, is that there's probably just over 600,000 of them. The story of why we don't know is a very long one that will, probably require alcohol. But so I wanted to talk a little bit about street tree census. This will not be the first time that Parks has embarked on this a crowdsourcing effort of this scale. In both 1995 and in 2005, Parks engaged hundreds of volunteers to inventory our street trees. These efforts actually catalyzed major advances in the way we manage our street trees here in New York City. The first street tree census identified more than 10,000 standing dead trees in our city streets, and that launched a big dead tree removal backlog effort to bring that down to 0. And since then, we have, barring major storms, removed all dead street trees within 30 days of a public request, which is like a huge leap for urban forest management. We were also, for the first time, able to go to City Hall and say, we have this many trees and this is how much money we need to properly maintain them, the same way that streets are maintained and repaved on a 10-year cycle. The 2005 street tree census, we ran it through an ecological services model that was developed by the Forest Service, and we were able to quantify all the amazing benefits that our street trees provide. And that actually directly launched and led into the Million Trees New York City initiative, which we are kind of in the end run of now. But unfortunately, even though these past 2 street tree censuses yielded all this great information and really helped us promote our programs, it really did not result in a good map. And so what you see on this screen is the results, kind of like the legacy of address-based inventories. This is the pain point that geocoding brings you. And so with that, I'm going to turn it over to Liz and talk about how, with TreeKit's help, the next street tree census is going to be different. We're going to be explicitly mapping these trees, and we're super excited about that.
Thanks. I mean, this data is accurate in terms of it well represents how many of what kinds of species are present, and it's not that bad on total number of trees. But there's a simple but elusive goal to simply be able to stand under a tree on the sidewalk and look at a map and confidently identify what tree you are standing under. That's all. That's all we wanted. So the TreeKit method, which has been going since 2010, has been focused on doing just that. It's designed for a team of 2 or 3 people to take a walk around the block with a rolling tape measure. It'll take about an hour for a team to walk all 4 sides of a block. And we totally avoid the use of GPS. The signals are blocked underneath the tree canopies, and the urban canyon in general means it's really, really inaccurate compared to simply measuring. So an oldie but goodie, bringing back a classic linear referencing method. I'm going to quickly run through how this works. Anyone standing on the street can identify where the corner of a block is. You can imagine how a rounded curve would get squared off to like a known point. And that point's also easy to identify when a GIS team is sitting in front of a computer. So the mapper simply walks down to the first tree bed, measures the length and width, scientifically hugs the tree, and figures out what species it is, and finishes off to the end point. For a long time, since this project's been up since 2010, we've been going on paper. We have stacks of these mapped trees because actually over 10,000 trees have been mapped by hundreds of volunteers using this method. And you can see how location is just specified by what street are you on, what's the start cross street, and what's the end street. So we duplicated that in an app working together with the Parks Department last year. And much the same thing happens. You choose what street you're on and then specify your start point. We just asked some simple questions like typing in the measurements that you just walked and ask a couple questions, and these are going to be changed for the upcoming census. I mean, the basics will stay the same, the scientific tree hugging and what species it is, but we're going to dump address and ask some more interesting questions that align with the Parks Department's operational needs, maybe some science from the Forest Service. And is that the alarm? Are we out of time? Oh, something else. And also some signs of stewardship. And you can just keep adding another tree until you reach the end of the block. A little bit of user feedback is going to help the QA/QC team. And I guess the most notable part of talking about TreeKit and this project in collaboration in the context of tonight's set of presentation is how much field testing and mapper testing, because I don't like the word user, has gone into this. Like I said, over 10,000 trees and stakeholder groups ranging from the city to the federal level, and also many grassroots groups as well. So TreeKit also aggregates the number of living trees by block segment so that you can understand the city at a glance, and all of this data will be released for useful purposes such as building other research studies on top of. Once the location is accurately described, it's very easy to hang off all other kind of research questions onto it. And also, as we mentioned before in the last presentation, a very active community group in the Gowanus Canal has loaded up 1,000 of their trees that they mapped using this method into an open tree map instance, and they're tracking their stewardship because they want to make their whole watershed better. I just want to, before I hand it to Jackie, I want to thank a couple people, like Phil Silva over there, TreeKit's co-director. His legs were featured prominently earlier in the slideshow. And also the many Geo heads who are in the audience right now, some who aren't, Sophia Parafina, Sandro Santilli and Andrew Hill, Frank Hebert, Aaron Ogle, and Sean White, and many, many more. This has been a very collaborative project, and so it's still growing. Thanks.
It's pretty safe to say that we would not be planning the 2015 street tree census in the same way without TreeKit and Liz and Phil. Just to recap, so the street tree census is it's a crowdsourcing project. It's something that's going to improve our operations. It's going to help us do our job better at the Parks Department. But fundamentally, it is about engaging with our volunteers and with the public through maps and data. And we really hope that, once the tree census is over, that that this idea of a shared street tree map will be what links kind of private stewardship efforts, taking care of our urban resource with our professional urban forest management. I do need to thank some of our sponsors who so far have already started to make Trees Count possible. So thank you. But really, I wanted to end with kind of like a call to action. We're GeoNYC. Dare I suggest that there might be a GeoNYC mapping party next year? I don't know. I really hope so. Stay tuned. We're going to be making a more kind of, our publicity push is really going to start off in the new year. We wanted to take this opportunity to share our project with the larger Geo community, and we really hope that you will join us next year out there rolling TreeKit. And there we go.
Do you have any questions at the microphone?
Hi, I was wondering if you guys had engaged at all with any of the community gardens. I live in a neighborhood that's very community garden heavy, and we have certified citizen pruners and people who I think would be really interested in helping with this project. And I was also wondering if you were mapping any of the trees within the community gardens.
Sure, that's a great question. So 2 great questions. The focus of this project is to map the street trees. Those are the ones that are, the ones that are the most kind of heavily managed right now. And so we needed to kind of limit the scope. A Forest Service study back in, when was that? Like in the mid-90s estimated that there's something like 5 million trees in New York City. So we are just making a dent in that. Do we have grand visions of mapping every single tree in New York? Absolutely, but one goal at a time. In terms of working with community gardens, we are in the process of starting our outreach to potential partner groups. We absolutely feel, we know that engaging with groups like community gardens is going to be a big part of what makes this possible, and we absolutely hope to empower all of you to actually hold your own mapping events and to kind of like own the streetscape and map the streetscape around your garden. So yeah, so we should definitely talk about that. I can't see anyone, but it's just.
So this is very interesting. I'm not a GIS person, so this may seem like an ignorant question, but is there any hope of automating the mapping process by using some form of image processing algorithm in combination with Google Maps, or as a first cut, and then maybe refining that localization with census data from humans?
So I'm not sure. There's been some efforts to kind of like heads up digitize off of aerials, and that has not kind of engendered the sort of data quality that at parks we're looking for. I guess my main answer to that is that this is a project that has 2 goals. One is a great new citywide map, but the second goal is really kind of parks connecting with our stewards and getting people in their neighborhoods engaged in managing and caring for this critical resource. So sure, I think there's probably an automated way. Maybe Liz wants to take this one and talk about it. But for parks, the public engagement and the stewardship engagement is as important as getting the data.
In addition to so much of the urban landscape tech innovation that you heard of from Robert, you might be interested in looking what the Spatial Analysis Lab at UVM does. They are working on a project to combine the beautiful 2010 LiDAR data that accurately describes the city's canopy with this kind of ground-up hyper-detailed data, such as bed size, trunk diameter, and species identification, and even how many individual trees might be in a particular canopy blob, to great, wondrous big data effects. But you might be interested in some of their other, they've essentially developed some artificial intelligences, upwards of 400 algorithms, crunching through orthoimagery combined with street view, and still they cannot get an accurate street tree count in that way. But they're always doing something awesome, so check them out.
Thanks. And I think there's a tree party coming up. Our next and last speaker is Steve Gifford. He's going to be speaking about Whirly Globe. Is that right?
Mobile apps, yes.
Yes, for government. They're going to set you up on your iPad?
Yeah, we're already set up.
Okay, great. Great, thank you. And then afterwards, we'll be going to a bar following the Tippler. That's on between 8th and 9th. What's the street, Thomas, again?
Between 9th Ave and 10th Ave on 15th Street.
On 15th. It's called the Tippler. So join us.
Okay. All right, as I mentioned before, it is really bright up here, I have to say. But anyway, I'm going to talk a little bit about mobile spatial apps for city government. I originally had kind of read the description wrong, and I'd gotten out my national government stuff, so I quickly put that away and did the city government stuff. So if anybody wants to see the air traffic app later, let me know. All right, so about me, I'm a software engineer, and I develop apps for a living on iPhones, iPads, Android devices, you know, that sort of thing. And I've been doing 2D and 3D development for a couple of decades now. I'm also an open source contributor, and I make a toolkit called Whirly Globe Maply. And what that toolkit does is it's basically a map or a globe toolkit that you use on a mobile device, you know, on your phone or on an iPad or something like that. It's distributed under the Apache 2.0 license, which makes it very friendly for commercial apps. And as a result, it's in a lot of commercial apps. And it uses OpenGL ES, which is kind of a fast interface for doing graphics on these devices. And that means it can achieve like a very interactive frame rate. So the apps you build tend to be very interactive. They can draw at 30 or 60 frames a second. And it can draw a lot of different features. Vectors, kind of image-based maps that we all use, vector-based maps, labels, markers, shapes, all that sort of stuff. And again, it's for iPad, iPhone, and Android. But talking about the features is really kind of dull. So let's look at some actual apps. And I'm going to do this one live because the weather lately has been really interesting. All right, so this is an app that uses Whirly Globe Maply, and it's called Dark Sky. And it's a pretty popular one on the App Store. Oops, keeps fighting with me here. And basically what it's known for is kind of displaying what the weather is around you and telling you if it's going to rain on you in the next half hour or so. That's kind of what people use it for. But it also has a display mode, and it'll show you, you know, radar in the near region. It'll give you kind of an animation over time, you know, all that good stuff. And if you zoom way out, it'll show you the weather over the whole Earth within the last few days. So this is one that a lot of people use. Kind of they put it on their iPhone, and they just use it to see if it's going to rain in the nearby area. And again, based on an open source toolkit. Okay, now let's switch back here. All right, here's another example. It's an app called Stratologica, and it's an atlas app. So it's used for education. Essentially, school teachers will use it to teach geography or history lessons or what have you. You zoom in far enough, it'll switch to satellite imagery, this is Bing actually. Sorry about that. But basically, it's kind of like a teaching app, and you can even make your own lessons, which is kind of their thing. So you can edit on top of the globe, you know, draw circles, put down labels, that sort of thing. But neither of those are really city apps. So let's go ahead and look at, some city examples. So I'll go through 4 quick examples that use city data or analyze city data or have something to do with cities. Okay, the first one is a map of London. Pretty straightforward. It's an offline map, which basically means that all the data contained for this London map is on the device. And if you want to get technical about it, that means it's vectors. It's storing all the raw map data, so it can look it up quickly, draw it quickly, and so on. And it can also do routing. This is a function of the app, I should say. Just pick up something random here. You can kind of route from one point to another. And hopefully it should show. There we go. So there's the route. So again, it's based on the open source toolkit, and it's kind of integrating with somebody else's routing engine. So that's an example of a city map. And then let's go back here. Let's look at some data analysis apps. These are the ones that I really enjoy. Kind of the most common uses of the toolkit are for maps and kind of atlases and weather apps and things like that. But the ones that I really enjoy are these crazy data analysis things. So this is a display of the current bikes available in the bike share system in San Francisco. So if you tap on one of the stations, it'll tell you how many bikes it's got available, the name of the station, what the capacity is, and so on. It's always great fun to figure out, like, where do they run out of bikes? And the bike share system provided this data so you can actually search, like, what stations are most likely to be empty. And this is actually one of the big commuter rail stations. Sure enough, that runs out of bikes all the time. Down here, there's a big tourist area down here. They run out of bikes a lot, that sort of thing. So you can kind of dig into this data set, and I should say this is actually powered by CartoDB. So we're making queries to a remote spatial database, and it's returning the results. So let's switch to popular trips. So we can look at the data, kind of analyze it, and say, what are the most popular trips in the city? All right, that's kind of an overall. And are there any patterns we can look at? Let's break it down by subscribers, which means commuters. And over here we see they're running from the train station over to kind of a big commercial sort of skyscraper-ish area over there. Well, you know, for San Francisco, they're not that tall. And you can also kind of look for one-time day customers. What are they up to? Those are tourists. And you can see this big spike over here running from Fisherman's Wharf over to, or I should say, ferry building to Fisherman's Wharf or back again. All right, let's look at another city example, this one a little closer to your hearts. This is the Pluto data set, which was this wonderful tax lot data set that New York produced for the 5 boroughs. And again, this is another CartoDB example because they made it public, like they put it in there in 5 of their tables, and then we can query them and do all sorts of fun things. So what we're doing here is as we move around, we're asking for data within those tiles. So the toolkit can kind of do this sort of tiling, so it's not asking for everything at once. And it's doing a little color coding too, so we can see the tall buildings. You know, they're more red, the shorter buildings in this kind of blue, and poke around in the data set. And every time we tap on it, it's sending off a query and figuring out what it's looking at. So that's an interesting city example. And this data set, of course, is great fun. And then the last one is another San Francisco example. I'm from San Francisco, so that's kind of why these are all San Francisco examples. A couple of years ago, San Francisco published data on Muni buses. They kind of instrumented a few Muni buses and counted the number of people getting on and off at different stops. So if we tap on one of these data points, we can see the passengers getting off there, passengers getting on, and so forth. And again, I'm heavy on CartoDB examples because this is another one backed by CartoDB. We can add in different routes, for example, and see where they converge, kind of look for the hot spots. And these will usually tell you the things you're expecting. Like right there, that's where a subway line lets out. There's another one over here, another subway line. And that's kind of where things converge. This is the downtown of San Francisco. So we see a lot of very popular stops there, that sort of thing. And you can also back off and get a general sense of where the traffic is. People tend to commute from the outer parts into the downtown and then back again. All right. So let's see, I think that was, let's get back to the slides. All right, so all of those may look fairly complex. I mean, we're doing iPad development, there's a 3D component, but it's actually not that hard. And the toolkit that I make, Whirly Globe Maply, it has a nice set of tutorials. So if you can, you know, if you've ever been tempted to do iOS development or Android development, it's actually not that hard. You know, if you do any web development, you can probably get started doing that. And there's a nice set of tutorials that start with a very basic, just kind of getting your first globe or map up on the device, all the way to actually that tax lot example for New York is one of the examples. So all the way to reading data from CartoDB and paging it as you need it. And it's actually very simple to get started with something like that. I've got a lot of people who do very simple apps with just kind of one data set, a base map, and a map or a globe. All right, so that was kind of my short talk. This is my contact info, and the part on the bottom is really the most interesting one. That's where all the information about the Whirly Globe Maply toolkit is, and including the documentation, reference stuff, and all the source code and stuff, since it is open source. All right, any questions? Oh, I have all the microphones. Does that still work? Does this work? Yeah, I can shout too. No questions? Oh, back there.
What was the app you were using in the demo to show us those data sets that?
Which one?
So you were demoing a bunch of these data sets just now in your presentation using some app. What was that? Is that part of the Whirly Bird thing?
Oh, it's just kind of a consolidated app that I use for showing demos. It's just sort of think of them each as individual things.
Okay.
Yeah. Right. Oh, over there.
I'll just bring the microphone over.
information from the bus cards, or?
They were actually, so the city of San Francisco tracked buses for a while, and they dumped out the data set for a bunch of different people to use. You can still get this data set for free. They're not tracking all the buses. San Francisco's a little bit farther behind than a lot of other cities in that respect, so they don't know where all the buses are. They seriously don't know where all the buses are. It's crazy. But so they were only tracking a subset, and they were just doing these counters, number of people getting on and number of people getting off over some of them. They didn't even have the train lines, I believe. So it's just kind of a subset, and you could kind of use that to extrapolate out some other things, but not some things, but not other things. So it's a limited data set, and they didn't really dump a newer version. So we just got that slice, and it's not like it's a continuous thing, unfortunately. Anybody else? Yep, over there. That one's called Stratologica, and it's on the App Store, actually. You can kind of, here it is right here. There's even a free option. You can just go in and kind of play with it. It's great fun. They haven't made a big splash with it because they mostly sell it to school districts, so they're not too interested in individual users, which I kind of think was a mistake because it's gorgeous. But you can actually go make yourself an account and play with it, and it's great fun. All right. Anybody else? Oh, back there.
For the weather app, Dark Sky, did you go with weather.com or AccuWeather info, and how do you get the best feels like and radar info and all that stuff?
Yes, I don't actually make that part of it. So that's a company called Forecast.io, I think. That's what they're really known as. I make the toolkit, and I worked with them to actually display it all. And I'm not sure where their raw data is from, but they do this pretty awesome data processing to get velocity information out of a storm, so they can tell you, their big thing is telling you if it's going to rain at your personal location within the next half hour or so. That's what people use it for. So they're analyzing the radar tracks, trying to figure out where things are moving. And it's pretty crazy. I'm not sure where their actual data comes from. Some government, probably one of those things you mentioned, honestly.
Is it going to rain here? Great.
It says no.
Well, he's working on that.
Yes.
Yeah.
We saw that London street map example. You talked a lot about how using like CartoDB or then doing cars, right, which is kind of a SQL text query, and then you've got the Pluto data, which is like a raster file that's generated by CartoDB. So what about the vector tile?
Well, this one's a little weird because it's actually interfacing to another toolkit, which is doing the tile rendering. Normally, the toolkit kind of does its own tile rendering. So if you want to support vector tiles from, say, Mapbox or one of the other forums, there's actually an app called Gaia GPS, which uses vector tiles in this toolkit. So it can do the full up, rendering streets and water and all that great stuff, and dashed lines and all the crazy stuff you do in vector tiles. It can do that level of vector tiles. So the whole enchilada, really. But what we're doing with CartoDB is more just querying and getting GeoJSON back, and then just kind of displaying those as shapes, really. So there's a lot of vectors involved there, but it's not the same level of intensity as you get with a vector map.
Sorry, we should.
Oh, sorry.
Yeah,
Yeah.
we should
Yeah, maybe ask me later.
Yeah. This is an excellent beer question. I'm sure there are many more to be had. So come join us. We're going to Tippler afterwards. If there are any other questions about GeoNYC or any other of the talks, let us know and join us for the next GeoNYC. It's January 12th, and for State of the Map, June 6th to 8th. So thank you for coming, and we'll see you next month.